In this lesson we're going to look again at vector journeys and adding vectors, but in a slightly different way. So the hexagon above here is shown with PQ, RS, T and U. We're told that PQ and TS are the same, so PU and RS are the same, and QR and UT are the same. What we have to do here is add PQ and QR. So if you think about it in the diagram, then PQ is here and QR is there, so the resultant vector is going to go along here. So we can say that that journey is exactly the same as P to R. Notice that the letters are set up nose to tail because you're going P to Q and Q to R, so it's really easy. You just eliminate the Q's and go from P to R. In this second one, just get rid of this, you can do the same idea, except there's three journeys here. If we looked at this first journey, we could really see that that's just going from T to P. So you could rewrite that if you like, TP plus PQ. And then you can see you're probably going to go from T to Q. But let's do it on the diagram. So we're going from T to U, and then U to P, which is just the same as T to P, and then we're going from P to Q. So instead of doing all that, then the resultant could just be from T to Q, and that's what we said earlier. So you can really just do it from the letters. This is really TP because it's nose to tail, and then you can eliminate the P's and go from T to Q. Okay, two to go. So we've got RS plus QP. So there's no letters in the middle. It's not nose to tail, so we have to think more about this one. So R to S on the diagram, that's down here, and we're adding Q to P. So what we can do here is we can put them nose to tail, which is down like that, and therefore the resultant vector is straight down. So it's R to T. Okay, one more to go. We can see that the first two here, if you look at them, now you can eliminate the Q's if you like, so that's just P to R. So P to R would be like this, P to R up like this, and then the last bit's P to U. So P to U like this. Again, rearrange nose to tail. So we could do that, and then you're going straight across P to S, and that would be your answer. You could take more time with it, and you could draw it out individually, and I'll do that just now if you're not following that. So individually you would go P to Q, and then Q to R, and then P to U. So same idea, shift this over, and then instead of going up and along and down, go straight across. Your resultant vectors PS. And one last comment on the zero vector, which again is fairly obvious, but if you've got a vector AB, which is 1, 2, we've got it here. It's actually 1, 3 And that diagram's wrong, I'll just change that. So we'll change that to 1, 3. And then we've got -1, -3. And I'll change this. Now when you've got A to B it's 1, 3, and you've got BA, which is in the opposite direction, which is -1, -3. When you add these two together, then they cancel each other out and you get 0, 0. This is called the zero vector. It's often just written as 0, and it occurs when you add two vectors that are exactly the same but in the opposite direction.